Hello, my name is Matthew McKnight. I am Programming Mentor for the Minibots 4536 and the Millisecond Bots 16806. And we're looking at what I call the 4 Horsemen of the FTC. If you have not yet watched the separation of concerns video, I recommend you do that so you understand what I'm referring to when I talk about concern. So we've looked at subsystems in the previous 4 videos dealing with the drive system, but there are 3 other areas of concern when you're creating a robot, and the other 3 horsemen take care of these: the OpModes, the robot, and the commands. Each of these has a significant role to play so that they can work together to make your robot fully functional. And before we go much further, I want to look at each of them so we can understand how they function together. Now, there are OpModes, commands, and robot. I think of OpModes as a map. That's its concern. How do you get from point A to point Z? And it defines the path. For example, it will say something like, go forward 4 inches, turn right 90 degrees, go forward 2 inches, turn left 45 degrees. It lays out the pathway to accomplish what you're trying to accomplish. In order to do this, it's going to use commands. It's never going to interact directly with the subsystem. It's going to go through commands to accomplish this task. This helps protect the subsystem so you do not have multiple things trying to reach into it. It also passes what's known as hardware map to the robot. Now, when a mode starts, it is automatically loaded with the information on the actual physical hardware that is on the robot. So in order for the robot to do its job, it needs to get the hardware map from OpMode. So OpMode will instantiate the robot and hand over to it this hardware map. The robot, its primary concern is creation and overseeing commands and subsystems. So it's going to instantiate the subsystems and it's going to instantiate the commands. This means the OpMode doesn't need to do that. And then it will make these commands, remember OpModes only work with commands, available to the OpModes. So it's kind of the logistics coordinator. It creates, instantiates the subsystems and the commands, and then makes the commands available to the OpMode. So the OpMode doesn't have to worry about that. Our third horseman is the commands. The primary focus of the commands is the process by which things get done. What it really ultimately does is it translates the OpMode's needs into the subsystem orders. So the OpMode says, go forward 6 inches. It doesn't care how you get there. But the commands has to take that and break that down into specific commands which will then pass to the subsystem to accomplish the task. It's sort of the worker of this entire system to make sure things happen the way they're supposed to occur. And so it'll do a lot of calculations to know exactly what to pass on to the subsystem in the appropriate way. The subsystems themselves, our primary concern is hardware. What they do is they take the hardware and they what's called virtualize. So they abstract it out from the actual 4-motor system into a 2-sided drive system, right and left. And that simplifies things for commands, because commands doesn't have to work directly with the hardware. It tells the subsystem what to do, and the subsystem then takes that and applies it to the hardware. This protects the subsystems, the hardware, by making them only accessible through commands, and then only even indirectly, because the commands rely on the subsystem. So these are 4 different concerns we have. The map of how we're going to get from point A to point B, the creation of the systems, subsystems, and commands we need to accomplish that, the process of translating those commands from map into commands for the subsystem hardware, and then the actual interaction with the hardware itself. So I'm going to give you an analogy which hopefully will make this a little bit easier. We have the event manager, who's an OpMode. We have the personal assistant, who is a robot. We have the contractor, who is a command. In this case, he's a tent contractor. We have the work crew, or subsystems. And they only work for the contractor. They don't answer to anyone else. See, the event manager has an idea. The event manager wants a blue tent. It's going to be 10 feet tall, 16 feet on a side, in the middle of the yard, and it's going to be blue. So in order to accomplish this, the event manager is going to reach out to their personal assistant, the robot, and say, I need the contact information for the tent contractor. The personal assistant or the robot, who has all this information and knows how to get a hold of the tent contractor, will tell the event manager how to do it. Then the event manager reaches out to the tent contractor and says, I want a tent that's 10 feet tall, 16 foot on a side, in the middle of the yard, and it has to be blue. Beyond how the contractor accomplishes that, the event manager doesn't care. It's just handed off the baton to the tent contractor to do it. So the tent contractor sits down and does calculations and figures out what the work crew will have to do. Then the tent contractor can reach out to their work crew and give them specific directions. We're going to use tent type 4. We're going to use 10-foot poles. We're going to position it 50 feet up from the bottom and 50 feet from the left of this area, and it has to be blue. The work crew will get to work. The subsystem will take that information, which has been translated into something they understand, and they'll put everything together, and there will be a blue tent. This process may seem overly complicated. Why, you might ask, why don't we just have the event manager do everything? And we could, but when you get into larger and more complex systems, just as in real life, doing that becomes ineffective. Having one person in charge of everything and not letting people specialize is actually more destructive and takes a longer time. So by breaking this up into different concerns, different specializations, we enable this system to work quickly and efficiently. And if anything goes wrong, we can usually track down where it happened and fix it relatively quickly. So with that, we're going to move on to looking at OpMode, robot, and command as we go forward.